Okay, so I'm going to take a quick jump and we're going to do a middle school skill. Combining like terms. Now, I don't know about the middle school teachers who I'm talking to, but I know that when I teach middle school, I have a really hard time explaining to the kids that x squared in x, you can't add those together. They're not the same thing, right? And algebra tiles really help me discern that because the elementary school teachers have done a fantastic job of introducing this single bar, and maybe even in 5th grade, they'll introduce this idea of just a basic x. And so by the time they get to me, we've got this guy and we can introduce this guy and say, hey, these two are not the same. We can physically see that they're not the same, and it is because of their areas, this x times x, right? Versus this 1 times x. And then this is 1 times 1. So we can build off of that prior knowledge with the multiplication, with the area that you guys, the elementary teachers did a fantastic job of building. So let's talk about how we might use this in the actual classroom. So if we have 3x squared plus 2x plus 3y plus 4 plus 2y plus xy. Okay, so a way that I do it without algebra tiles is I just, circle the terms that are like terms that go together. But what I can do here that makes life super nice for a lot of kids is when I see 3x squared, I'm going to come over to my x squared pile and I'm going to say, okay, 1, 2, 3. That represents this x squared pile. Well, then I'm going to come to my next term and I've got 2x. Okay, well, great. 2x. Okay. And then 3y, come over to my y pile. I've got 3 y's. I'm going to keep them orange for now. Okay. Then I got 4 regular tiles, the ones we're comfy with already. And then I got 2 more y's. And then I have an xy. Okay, so I've got all of this here. Well, to figure out my final solution and figure out what terms I can combine, I'm actually going to move these tiles so that I can put all of them together. So really all I ended up doing for this problem was moving these guys together. But then I can look at my final problem and say 1, 2, 3. Okay, I've got 3x squared. And then I've got 2 x's still. Then now I've got 1, 2, 3, 4, 5 y's plus 1 xy and plus 4 littles. Okay, and again, this is great because it's a visual way for them to physically move stuff around and combining like terms, but it also is great to show them that x squared, xy, and then if we have it, y squared are all different. And something else that I like to do in the middle school level, I pull in more complex terms. So I pull in the xy and I pull in the y squared a little bit sooner than a lot of people because I use tiles like this. Now, middle school teachers, you may be telling me, well, what about negatives? We work with those a lot. Well, we can do that too. And that is one of the reasons that I told you that we will be using the other side. So let's say we have x squared plus 5xy minus 2x, we'll do 2x squared plus, I don't know, negative 3xy plus 2 minus y squared plus 3y squared. Sure, that works. Okay, so the first thing I'm going to do is I'm going to get all my tiles. And this first one is no different than what we've been doing, just, your regular x squared. Right here, though, or actually not right here. Right here, we've got 5xy's. Oh, I'm going to change these numbers so I have enough. I'm going to make that just 1xy. So I've got 1xy. And then we've got minus 2x squared. So this is where it gets a little bit different. When I have a minus, I'm going to use the red side. And this helps me with negative numbers. Not just negative numbers, but also the negative coefficients in our terms. So we've got negative 2x. Okay, I've got that. Negative 3xy. So again, we're going to have this negative here. Negative, negative, negative. Okay. Positive 2 over here. Negative y squared. We've got this guy right there. And then plus 3y squared. So 1, 2, 3. Okay. So now we have to combine these like terms. And what's great about this is you can literally see our zero pairs. So a positive x squared and a negative x squared is a zero pair. And so it's not there anymore. It equals 0. So we're left with this, okay? Here, we can find another zero pair, right? So x positive xy plus a negative xy is going to give me 0. And then we also have another zero pair here. Negative and a positive gives me 0. And then I'm looking for any more zero pairs, and you can only make zero pairs with things that are the same exact shape. So if a student says, oh, well, I can cancel that out, no, you can't. That's not a zero pair. They're not physically the same shape. They don't line up. So there's no more zero pairs, and so what I'm going to do is I'm going to say what's left. So I've got a negative x squared minus 2xy's plus 3, or nope, not 3, 2y squared, that's 1, 2, plus 2. Okay, and so that is combining like terms with both positive and negative numbers. Thanks for watching.